Hi, good morning. I'm Oliver Gao. I'm the director of Cornell System Engineering Program. I have been really lucky and fortunate to conduct what I call this system conversations interview with the prestigious speakers that we bring to Cornell System Engineering Program, which we call Ezra Roundtable System Seminar Series. So today, I'm really delighted to have Dr. Conrad Tucker. Actually, Conrad is the author Hampshire Career Development Professor of Mechanical Engineering at CMU, Carnegie Mellon University. He also holds courtesy appointment in machine learning, robotics, biomedical engineering, and also the Scilab security and the privacy research. So his research focuses on the design, not only designing it but also optimizing the systems through the acquisition, integration, and mining of large scale data. These are all very very hot and very important areas. So Conrad, welcome to our conversation series. When I was I spent quite a lot of time visiting your website and looking at your exciting research, and I was wondering, wow, I remember you got your PhD degree in 2011.
Yes.
Right. So now it's 2020. It just within 10 years, look at what you have done. So I'm very curious, and I believe our audience would be very also curious to learn more about how your career started and how you evolve into such a big figure looking at all these important issues for our society.
Thank you very much, and thanks for having me as part of this program. I'll start off with my undergraduate degree at
Yes,
Rose-Hulman Institute of Technology. My degree was in mechanical engineering, and after graduating, I spent a year in industry working as a process engineer. And that's really when I started gaining interest in the systems approach to engineering. I was in charge in industry of a manufacturing facility, and if you think of that, as a system of inputs and outputs. And I really became curious as to the theory of how systems operate, which motivated my going back to grad school at the University of Illinois, where I enrolled in the Industrial and Systems Engineering program. At the time, it was a very new program, and the goal was to try to get more engineers to think like systems engineers. And I was fortunate to have an advisor, Professor Harrison Kim, that came from the traditional optimization and systems design background.
Yes.
What I did as my PhD was to explore how machine learning could enhance the efficiency of the product development process. So my PhD was quite focused on the early stages of product design. Customer needs analysis, modeling the concepts of a product or a system. Fast forward 10 years, as you rightly have explained, that my research has actually expanded beyond the product design. We do work in generative modeling, healthcare, systems engineering, robotics. For looking on the outside, it would seem as though these are disparate domains.
Yes.
But I think what has made us successful is really understanding the unifying concepts that link these different applications together, and that's really the systems engineering component at its core.
Yeah, wonderful. And I think so Conrad, you mentioned, I really appreciate you said that in between your, after you graduated from college, actually you had, about 1 or 2 years of working experience. And also, as you mentioned, in your working experience, actually, you really redeveloped your thoughts and that you made your decision to come back. And I think that's beautiful. And that's actually, I think, probably even in the work, that probably helps you, develop a better systems, like a perspective.
Right.
Right. Yeah. So,
right. And the typical undergraduate degree focuses primarily on, introducing theory, concepts, especially for engineering equations.
Yes.
I think what an industry experience does, be it a full-time opportunity or an internship, is really connect the theory with how it works in the real world. So I was fortunate to have this industry experience because it really gave me an understanding of mechanical systems, what it means for something to be optimal, what it means for a system to be stable and predictable. These are all the types of engineering that go into enhancing the efficiency of the world.
That's great. So I think, Conrad, I would like to, because, when I was looking at your work and several keywords kind of, that got into my mind, right? It's, one thing is kind of engineering design, right? Because I'm an engineer, you're an engineer, and we do a lot of design. And of course, design can be laborious and also time consuming, right? The one is design. And another thing that I think, artificial intelligence. Right, and what I can see is actually you are connecting these two together, and more importantly, and also I saw like you were involved in initiatives like in the Scilab Africa, the initiative. So which means I can see that you are trying to use artificial intelligence to either disrupt or revolutionize engineering design to serve the social benefit across the world, like including the African country. So I would like to take this opportunity to see, because when we as researchers, when we are trying to identify our next initiative, we're always thinking about, okay, what do I want to do? What motivates me? And what are the the societal challenges I can use my limited lifetime to contribute to. So in your view, what do you see as, some key system challenges that you would like to use your career and your work to address?
Well, that's a very ambitious question. I'll try my best to address it as posed. If we look at the engineering design process as it stands, it requires a lot of domain knowledge to be able to make a contribution in this field. In my opinion, that leaves out a lot of great ideas that the average person may have, that they're unable to translate that idea into a real world product. So one of my motivations has been trying to reduce the barriers to entry when it comes to the process of creation, when it comes to the process of idea generation, all the way to realization. And when we look at other disciplines, whether or not it's in the entertainment industry or in speech and communication, what artificial intelligence has been able to do is democratize access and reduce the barriers to entry into domains that were in the past reserved for highly specialized talent.
Yes, I like that idea. It's kind of, we do this, you say, democratizing, this kind of design. And you're right, it's kind of, so far in our society, from the designing of, the scrapers to the designing of computer chips, right? They do belong to, the small size professional groups of people. They're doing it. But are you saying that by using artificial intelligence, as you mentioned, you want to reduce this entry barrier? Somehow, can you imagine, if we're using, under your vision, someday, would that be possible? Engineering design would be commoditized, such that, you and me, we could lose our jobs.
Well, I would say just expanding. So, for example, there are, let's take media, for example.
Yes.
Media has been democratized because of the availability of social media. Now, that did not necessarily replace your traditional news reporter or anchor. But what
That's
it did was provide access to everyday individuals to report on news stories. In some cases, faster than someone sitting in an office 1,000 miles away.
Yes.
So it would be great to see the engineering design process democratized in that way, where, you know, my children have an idea for a toy, and they don't have to wait for an expert designer that they've never met, that has very little understanding of what their needs are, to be able to take their idea and have it come to life. That is really the vision, and you know, access to data and technologies is the hope is that these barriers will be reduced.
Yeah, that's beautiful. I really like that idea because you know, people have been comparing like at the core of artificial intelligence is really learning, right? You know, but of course, you know, learning is done mostly by, you know, pattern recognition and then codifying it and then, you know, kind of implementing it in the future, right, practice. So when I'm looking at that, so of course now we see two paths. One is business usual, or this traditional engineering design, and another path is like, you know, the path you envisioned, this artificial intelligence enabled or even revolutionized engineering design. So can you help us, you know, kind of delineate the key differences or the key novelties that you see in this, you know, artificial intelligence backed engineering design, and what are the key features, what are the advantages?
Right. So I think artificial intelligence can play a role in the traditional engineering design process and in this kind of democratized process that I described. If you take your traditional aircraft manufacturer or automotive, there's a lot of homogeneity in terms of the way the engineering design person was trained to become that expert.
Yes.
So inherently there's a bias in how that design team thinks.
Also subjectivity.
And subjectivity.
Yes.
So what artificial intelligence may be able to do in these spaces is to explore components of the design space or search space that were otherwise not explored by this engineering design team. If you think of aircraft, we have a design for what an airfoil looks like, and that's. But what if there are other ways to create lift that we haven't really thought about?
Yes.
And you know, what if there's a way to have you know, artificial intelligence enhance the efficiency in which we explore these design spaces? So I don't think AI is only for this kind of ad hoc everybody designing. I think it also has an opportunity to help in the traditional well-established industry.
Absolutely, I very much agree with you. You know, it's this reminds me, you know, in engineering we have been talking a lot about design, like engineering design, but engineers, we seldom ask what and who do we design these things for, right? So maybe we, you know, in a corporate environment, maybe the marketing people will tell engineers, okay, design this. But you know, now I teach a course in system architecting, right? You know, the start of it's really like, you know, the stakeholder needs. You mentioned the example earlier, your child like wanting a toy, but and then if it's a traditional engineer, they just design. Okay, they probably design a toy based on their prior knowledge, understanding of the need of the children. However, now what you are saying is really artificial intelligence can even, you know, through the learning or through the data, even probably just, I'm just imagining if there is a robot, you know, talking to your son for just 5 minutes, and then they will translate that thing in a customized. So here, what I want to say, so what do you see the potential of AI in discovering human being versus designing for human being? So
Right.
So
you know, if you look at the existing, just think about how many ideas that exist that are generated by all people right now. and how many of those actually come to fruition. All of us are constrained at the moment to whatever someone else thinks that we would want to have, whether or not it's cars or these chairs, or because many of us are constrained either by the cost or the knowledge that's needed to create these. I imagine this, and this is not this is not unique to engineering. There used to be a time where people didn't have their own printers at home, but now it's almost synonymous to households.
True.
So as the barriers and costs of these technologies come down, I envision something similar happening in the engineering design space, where you have these abilities to design for you as an individual.
I agree. So, when you were talking, I was just thinking along, your words. It's really, mechanical engineer and also all this design, similar all this engineering design, like designing buildings or designing cars, for the traditional engineering consideration and also safety consideration, we know that most of the engineers, their daily job is to follow the design code. They're just doing all these things, right? So, but somehow now with this AI component, I feel I'm just imagining the traditional engineering design somehow becomes the arms, hands, and legs, while this AI really becomes the brain part, right? And then still and then the AI because AI is not going to replace the real manufacturer. Of course, they're going to direct, guide the manufacturer, but they're going to. So in the end, when you convert the ideas into a real product, probably the traditional manufacturer and the engineer still play a very important role because they're. But in the meantime, it's really the designing and also the ideation of the concept. And this part, I think one key thing you mentioned, the design space, even though throughout human history we have innovated a lot, but in comparison to the capability of AI being able to explore even the design space, what we have achieved is probably very tiny.
In the grand scheme of things, I think there's a lot of understanding of the universe that's yet to be untapped. I think in order for AI to have these contributions, of course, there needs to be more access to data, sensing modalities. It's not, we're not at the stage where there's this AI designer that has this type of knowledge, which brings us to this opportunity for these algorithms to start understanding the physical concepts of physics, of the laws that govern the way the world works, like gravity or forces. So now you start getting more fundamental. These algorithms are, because in order for an AI to design this chair, for example, there's one thing of the geometry, but it has to be functionally sound to be able to hold, someone's weight or the force. Well, how is an AI going to be able to understand that if it's not embedded with an understanding of physics? And now what we're seeing is lots of researchers that are active in this space that are looking at encoding the physical representation of the world into the architectures of these algorithms themselves.
Yes, I totally agree with you. So this AI, the keyword is really intelligence. Intelligence. Usually, intelligence is connected to creativity, right? And somehow, our current design, actually somehow it not much creativity there. As I said, we have to follow the codes because otherwise, if you make mistake, it causes some, clarity, right? So, however, it's intelligence, especially AI, being applied to creating new things. Of course, when we talk about AI, there's also human intelligence. So what do you see as the advantage of AI in comparison to human intelligence?
Well, I think that both human intelligence and artificial intelligence are not these static things. We're constantly learning and
co-evolving.
And even for human intelligence, there are different echelons of intelligence. You know, intelligence capabilities of a 5-year-old are quite different from an adult.
Mm.
And I think similar types of demarcations should be made when we're describing AI. And unfortunately, that's typically not the case, where we think of AI as just this one static, all-encompassing thing. I mean, in biological systems, there are different types or scales of intelligence.
Yes.
I do think that there's going to be this co-evolution of human intelligence and artificial intelligence. I think that the future of what people are going to do, how the jobs are going to evolve based on what machines are able to do, it's an open question. Mm-hmm. I often pose to my colleagues in this space the rate in which humans acquire new information. Let's say someone loses their job and now they have to retrain to a newer job. And the rate at which artificial intelligence is expanding. Hopefully, humans were able to retrain in new fields faster than those fields are becoming obsolete. That's really going to be the question. And I think that's going to take a rethinking of even the education system.
Yes.
Our traditional education systems have been quite the same for many decades. 4 years for an undergrad degree and however many years for a PhD. Is that model going to be viable as the rate of AI accelerates to these new domains?
That's a very, you raise a very profound question. You touch upon rethinking our higher education or our whole education system, right? Somehow I guess you're probably hinting towards the lifelong learning.
It has to be. I mean,
yes.
And lifelong learning with maybe new ways of delivering knowledge, delivering content. Yes. Maybe in this asynchronous idea that we talked about, trying to optimize for a specific individual. If someone is more efficient at acquiring knowledge at 8 p.m. at night, and they acquire that knowledge 40% faster, then that's when I want to deliver this information.
Yes.
So that it doesn't take 4 years for everyone to acquire this new skill. We're optimizing based on the individual characteristics, and I think that there's a tremendous opportunity for our education system to adapt as the world around it adapts.
Yeah, absolutely. I think your question comes at such a time because during the pandemic and the post-pandemic, I think one of the hit is really to the higher education, and we especially this system engineering program here at Cornell, which includes both on campus and this learning, and actually we started asking ourselves, what is the core value an education program / experience deliver to a student? Because during the pandemic people are away, but you want to maintain that. But now we have reopened and people come back, and you can see this before and after and during all this delta change that get us started thinking what exactly the value of education, right? Of course you said probably knowledge, right? We can somehow, I guess, kind of in the future, right, even higher education can be commoditized because all these online courses, these things. But then what is the real thing? But still I think we would love to go to a university. We would love our children to go to a university. And then what will they gain?
Right.
Right. So.
And at what cost? Right?
Yes, at what cost?
What cost?
Yes.
And look, the world is changing around. I think academia has had a monopoly on knowledge for centuries or even longer.
Yeah.
But that doesn't mean that monopoly is permanent. As the world around continues to evolve, there needs to be a rethinking of what the value proposition is for the learner, and whether or not that value proposition has to be limited to 4 years. I really like the idea of lifelong learning. I think there's a tremendous opportunity. I'm surprised why it seems like a tremendous opportunity for new talent, new revenue streams to engage a graduate of any institution for whenever they're seeking to learn a new, what is AI? I may not want to go as deep as a PhD researcher, but I want to be competent so that I could bring it back to my business operation. What are the mechanisms right now to accelerate that or facilitate that? I think there's a tremendous opportunity for higher ed to connect with these opportunities.
Absolutely. And also, now see, Carnegie can see you are absolute a system thinker, right? You are right. This probably you can see that it has very little to do with your daily research, right? So, in your research, of course, so far you can see that we talk about the relationship between engineering design and AI, and I can a certain leg in your research is really data. So I would like us to be able to make the connection between AI and the data. Of course, you've been doing this. Yeah, please tell us about the interaction between AI and the data, and what role and why AI needs data, and why data can in what way data is so important in AI for engineering design.
Yep. So when you look at AI, it's a data-driven way of understanding a system.
Yes.
And what we've seen over the past several decades is the availability of sensing systems, the cost of those and the ubiquitous nature of those come really down. Without this breakthrough, I don't know if we would be where we are with AI and its deployment. So that's the first. The sensors have become cheap, data has become cheap, storage has become much cheaper. Now you have the algorithms that are just learning from that data and trying to create a mapping. I think of a neural network as like a system.
Yes.
This idea of systems thinking, of mapping inputs to an output, and you have some function approximator that just learns how to.
Yeah, that happened in the neural.
So it's a system like we do in systems engineering. So I think that the trend of access to data and the ubiquitous nature of data is going to continue. I think our mobile computing devices are an example of that. And because of this access to data is really how my lab expanded from just looking at product design to work now where we're doing healthcare. It really stems from the access to data. I can give a short story how we came into the healthcare space. So I think of the human body also as a system. I think of
Absolutely, yeah.
And so if you think of a system, okay, so either the engineering designer is creating the system, in the case of a car or a plane, or the system is created by biology, like a person.
Yeah.
And what we want as engineers is that system to operate in a way that is predictable and as intended. So when a human body deviates from this steady state, we call it a disease, right? So our advancement in the healthcare space just came from this modeling of a human as a system, and to try to use sensors that are available to observe when the system deviates from
different states.
In different states. And what we're using is a computer vision approach that's looking at identifying the physiological signals of a person to extract heart rate, respiration, and other types of signals, so that you can use these extracted signals to quantify when the system is out of normal operating condition. So that's how we got into healthcare. Is again the unifying theme here is systems, whether or not it's a biological system or a man-made system. A system has operating states that you want to be able to predict. And
absolutely, and I think that is such a nice. It's not even an analogy. It's just a very direct application, because you know that in system science, there is this very important branch, cybernetics. Every cybernetics has a deep root in what you just mentioned, like the biological systems, human from human body to plants, right? Yeah.
Right. So of course, I do not claim to be a health researcher, but what we are is a systems research lab that understands that the principles of systems engineering can be applied to humans as a system, automotive as a system, a computer network as a system.
Yes.
And this is why we've been able to expand to these different domains. Because I do get asked that question a lot. How is it that your lab is able to do so many diverse things? And it's because there's a unifying principle that we are operating in.
That's beautiful, and you're right. It's a kind of when you see that unifying theme as a way such that actually, because you are working at this this fundamental level, right? That's simple, and then applications, they're just different realizations, right? Of the cases, So this is really exciting. So of course you are really at the frontier of this different this research theme. So can you share us, like, of course, while we're excited about this research direction, like what key challenges do you see for your area of research, and what are your initial thoughts to tackle those?
Right. So I'll start with the human capital challenge as a first step. I think that the students that we initially engage, when students join my lab or are considering exploring joining our lab, there's sometimes an initial hesitation of, well, you're working on so many things, I wonder if I could become an expert in this. And so there has to be this first reassuring that if you operate at the systems level, these are just applications of the system. Healthcare, cybersecurity, product design. But I think sometimes people get distracted by the application level, not understanding the unifying systems approach. So that's the first challenge, is being able to communicate that with students, researchers, the broader community, that if you embody the fundamentals, then it doesn't matter if you can apply it to healthcare, you can apply it to vehicles.
Yes.
But people, it's a very difficult. It takes a while to explain to convince people that's possible. Another along that line, I do think that the just access to diverse data sets it's critical to making sure that these AI algorithms don't overfit to a particular context. And I think that's one of the strongest cases when there's this effort of enhancing diversity across academia and industry. I think the strongest case should be that, yes, there's a moral case, but I think an even stronger case is that this is going to provide you access to diverse data sets that make your algorithms more generalizable and deployable. I mean,
yes,
it seems like a no-brainer that you want your algorithm to have as
be trained,
and have as broad as reach as possible. So organizations should be incentivized to have this type of diverse data sets because it gives them a competitive advantage.
I totally agree with you. So it's really, I think it's one thing, this machine learning or AI, it's really leveraging across multiple. It's not just, I applied it to this company but this company, there are so many peer companies, they are serving all this, all this market segment. But if you have access to all your peers, actually this morning we had a meeting, with MITRE, they're talking about this, time-based air traffic management. But imagine you have an airport, you have all these airplanes coming to this airport. Of course, these airplanes belong to different airlines, right? So now from the airport for the aviation traffic control, right? You want to control all these different airplanes coming from different origins and coming here. The earlier you have information, and also the more transparent all these airplane information are shared with this air traffic management system, that actually improves efficiency for every one of these airplanes in their landing. However, it matters if they're not willing to share their data. So like coming back to your example, I think the keyword is really leverage. However, to leverage, you really need to have this ubiquitous access to that. So even nowadays, do you see the key barrier that prevent accessing data across multiple institutions or stakeholders?
Yeah, I mean that's a tremendous challenge, not only in industry, but even I just came back from a symposium where the DoD is trying to think of how to create these standardizations so data can be shared across different departments. I think one of the main challenges is just the way that different organizations represent their data. I mean, currently, as great as neural networks are, there's a huge constraint on the input side, which is the dimensionality or the way that the data is represented. Thankfully, my understanding of our human brains is, I could represent this room here, and I could go outside and represent a different. I don't know if we deal with these kind of rigid representations of our input space when you think of our different sensing modalities. So I'm not sure which will come first, if it's coming up with algorithms that provide more flexibility in the representation of the data, or having organizations come up with a standardization for their data. Maybe both will happen, but I think at least one of these is needed.
Conrad, I think you raised so many good, very fundamental questions. It's probably because you are really at the forefront and you see the challenges coming to us. Not even many people are able to see that. Just the point you just made. This data sharing. Of course, you talk about we need to standardize the data, and even that standardizing the data or the protocols for recording or storage in the data, that is still addressing like the technical aspect of data. But what I'm thinking for different institutions or different DoD or different stakeholders, I'm not sure that the major barrier is that all these companies, they don't know how to store a data that can be shared, but rather it's really
their willingness.
The willingness, and also can I trust that? So from that, actually, I remember, I feel like in academics, usually we, in the society, we play a role of being independent, being objective, being not taking any stand. So essentially, I heard one word people use, academics is an honest broker, such that government and even competitors, in the industry they are competitive, but they come to this one because they trust you. So what I'm trying to say is that in addition to addressing those technical technology problems in the data sharing, do you see another layer of the mechanism design and even institutional infrastructure? How can you build trust? As you mentioned, how do you build incentive? It's not only incentive, because if you build a trust, people probably don't even need incentive. So where do you see what do you see in that aspect of the social infrastructure in data sharing and collection to enable the power of artificial intelligence?
Yeah, that's a fantastic question. I think that the current reward system that we have in industry and government and academia, as it pertains to data, is centered on data being a competitive advantage. And therefore it's difficult for a competitor to voluntarily share their data if they perceive this as being their gold, their differentiator.
Yes, that's right.
There are ways of, talking about academia being the broker because of the neutrality. There are ways that we could minimize these concerns by either making what's shared some type of a latent representation of, so that you can't reverse engineer data. Really, what we want to share is the knowledge. Knowledge. You talked about the
that's right.
air traffic control.
Yeah.
Well, just knowledge that these aircraft should have these type of flight patterns or characteristics, and not necessarily the raw data. So maybe we should focus less on coming up with ways to standardize and share data, and ways to coming up with this common knowledge, this common language that could be communicated and agreed upon by.
I think that's a very key point. And I think you made it. You made me think of, the car dealers. That I can kind of one car model like a GM, Chevrolet. They have all these car dealers across the country. But sometimes the advertisement campaign is actually done by the car manufacturer instead of by the car dealers. Right. If you think the car dealers as all those industry competitors, right? But is there a car manufacturer who can do all these? Because the key thing in the end is that it's not that like AI, like imagine if in your AI group, you are collecting this data. It's not that you are stealing this data away to generate something to benefit you or to benefit just one stakeholder. Actually, you are going to generate that knowledge
to benefit
benefit the whole.
Right.
So which actually your strategy is really kind of by using AI towards that pooled data, you can generate knowledge that will expand the whole pie.
Right, for everyone.
Yeah, for everyone.
I think academia has been the leaders in the dissemination of knowledge. This is a perfect example. I think academia has been a leader in the dissemination of knowledge. Many different organizations and societies have benefited about having this open model. So I think there is an opportunity to create something similar in the data space.
I see, but at the least it's resistant. But at least it sounds like earlier, what you view as a barrier simply the current status versus the vision you just shared. There is this gap, because when we discuss, like you and I, we can see that maybe it's probably an education gap of those stakeholders to let them see this bigger pie, or what is preventing because as you're saying from the DoD, the workshop or the conference, what is preventing all these stakeholders seeing this bigger pie?
Let's take autonomous vehicles, for example. 100 years ago, the competitive advantage, what differentiated Ford from GM or so, is how powerful the car is, how shiny and things that are more mechanical or electromechanical.
You're right.
Nature.
Yes. Yeah.
And the cost, of course. If you fast forward now and ask, well, what would make one consumer purchase one autonomous vehicle over another? It's how well this system is able to be autonomous, as an example.
Yes.
So if the capabilities of autonomy are a function of the data of this company, you could see why it would be difficult for them to agree to share this across, even though it would make everyone safer in the entire transportation system. But if a customer is going to buy your autonomous vehicle over another one because it works better, that organization is less that becomes their competitive advantage as opposed to the horsepower or other things. And I think that's really what the challenge is. And I don't know what the solution to that is.
Carnad, I think you gave a beautiful example, and that kind of stimulated me to think about it. It's really, let me try to think about, and let's see if you agree with that. Are you saying that the specific problem like this, this mindset of sharing data versus the value of sharing data, this gap, could that be because that while our society, while every one of us nowadays, we are entering into the AI era, but in the meantime, our mindset, our social and institutional infrastructure are still in the industrial age.
Yes.
I feel that's really because it's really a mindset and a paradigm gap. It's not really about technology.
No, this is a problem you're right. It's a mindset problem of our. It's not just the consumers. It's the entire system that's built upon an economic reward system of whoever differentiates at a cost that and quality that someone is interested in, they win, right? They win.
In the short term.
In the short term, yes.
Yes.
But that's goes back to what is the function of a firm to maximize shareholder value only for that specific. This is the system that's created. Talking about systems, the current system is that one manufacturer is incentivized to maximize only the value of their shareholders, not the shareholder of society or another. So selfishly, they are going to make decisions consistent with the definition of a firm to do that. So it may require rethinking what is going to be the reward structure. If we do want organizations to kind of share their data, well then what's going to be the differentiator?
Yes. Wow, you brought this, like, I feel like all the way to the very deep root of our society. Unfortunately, I think we are probably running out of time. I heard like probably Jamal is outside. Mm-hmm. This is really an enlightening discussion. I very much appreciate your time.
And I'm sure there's hopefully very smarter people than I am thinking of these questions. But I do think these are the 21st century questions. I think there's an opportunity to think about how we're going to make AI more accessible and enhance the efficiency of the systems that we currently have. But that's going to require us to rethink this data problem that you're talking about and reward systems.
This is wonderful. Thank you very much.
Thank you very much for your time.